Okay, so welcome back. Now, in this example here, we've got this series, and what we're going to do is we're going to write out the first few terms and see if we can rearrange this to make it look like a geometric series, and then we'll be able to pick out the A and the R and be able to determine whether this is convergent or not. And then if it is convergent, if it does converge, then we'll be able to see what it converges to. If it diverges, then we're done. So now, let's write out the first few terms. So this is going to equal what? Well, when n is 1, we get what? We get negative 3 squared over 4 to the 0. And then when it's 2, we get negative 3 to the third over 4 to the first power, plus negative 3 to the fourth power over 4 to the second power, and so on. Okay? So if we rewrite this, I'm going to factor out, it's got a common factor here of negative 3 to the negative 3 squared, right? So I'm going to factor that out. So I can rewrite this as negative 3 squared, or what I mean, not factor it out, that's the wrong term. I'm going to bring it out to the front is what I meant. So this is going to be negative 3 squared times 1 over 4 to the 0, which is just going to give me 3, as you'll see. Well, actually, you know what? Let's just write it as negative 3 squared. So this is just going to be negative 3 squared. Plus, and then I'm going to write this as negative 3 squared times what? Oh. Times negative 3 over 4, so there we go, like that, plus negative 3 squared times negative 3 squared over 4 squared. So then if I rewrite this one more time, this will be negative 3 squared. Well, actually, you know what? Let's just do negative 3 squared, which is 9, right? So this is going to be 9 plus 9 times what? It's going to be this whole thing raised to the first power. So it's going to be negative 3/4 to the first power plus 9 times negative 3/4 to the second power plus 9, and then it's going to continue on, negative 3/4, oops, not 3/3, 3/4 to the third power, and so on. So now we see that this has a common factor of 9, so that's our A, and it has a common ratio of negative 3/4. So in other words, this can be rewritten as the series n equals 1 to infinity of what? 9 times negative 3/4 to the n minus 1 power. And now we see that it is a geometric series where A is equal to 9 and R is equal to negative 3/4. We see that the absolute value of R is less than 1. So that means this series converges. And so what does it converge to? It converges to what? A over 1 minus R, right? And so this is going to equal 9 divided by 1 minus negative 3/4, which is 1 plus 3/4. So this is going to be 9 divided by, 1 plus 3/4 is 7/4, which is equal to 9 times 4/7, or in other words, 36/7, which is the same as 5 and 1/7. So this does converge, and it converges to either 36/7 or 5 1/7. And that's the answer. Okay, we'll come back and do another one.